AMRs, they are another material handling solution. They are a resource that you can use to execute tasks, but they don't do everything. They're not flexible to the extent that a human can be, but they're more flexible in the context of what conveyors can do, even pick-the-lights or ASRSs. So what are some of the fulfillment environments that lend themselves to the application of AMR solutions? The primary area where these are very traditionally been very successful at is the idea of a B2C pick, pack, and ship environment. I'm picking product into cases, cartons, pallets, whatever you want to call them, totes, and I'm getting them out the building. There is some application success and presence in a B2B fulfillment model. Obviously, in a B2B model, you could still have the pick, pack, and ship type situation going on, but you may also be doing case picking, building mixed SKU pallets that you're going to ship LTL to your business customer. There has been a long history of AMRs and their predecessor, AGVs, automatic guided vehicles, being involved in internal moves, conveying material without having a conveyor obstacle in the middle of the floor. A shuttle move that doesn't need an operator to drive back and forth all day. The key is finding the right application for that you need an AMR for, and then applying the right AMR to be able to execute in your environment. So what are some specific examples? And we're going to deal with these a little bit more here. The idea of a goods to person type environment. This is a goods to person is a variation, if you will, on batch picking. I'm taking a bunch of product to a packing station. For example, a pallet worth of product that I'm going to turn into individual envelopes with one thing in each envelope. That's a batch pick, right? Well, a goods to person approach is very similar to that. Not necessarily the whole pallet movements, but very similar to that. Then you have the order to person variation. This is where the operators are staying in a zone. They're not walking around a lot. And the AMR goes to them and asks them for specific stuff for the carton, the totes, whatever it's carrying. This is a variation on cart picking, quite honestly, in the sense that you would populate the cart with cartons, totes, whatever, you assign them to orders. The operator would typically then use a handheld, drag the cart behind them, wander through the entire warehouse, and gradually fill up all of the totes, and then take them back to a packing station. There was one example anecdote given where an operator was talking about how they love the AMRs. And the reason they love the AMRs so much is, he says, before we got the AMRs, I was doing cart picking through the warehouse. And by the time I got the cart filled up, I was carrying it, dragging behind me 400 or 500 pounds. And that's kind of drudge, right? And then he said, on top of that, I was using a step counter on my wrist, and it was telling me I was walking anywhere between 10 and 12 miles every 8-hour shift, dragging 400-pound carts. This was tough. When the AMRs came along, I love them, man. I don't drag the carts anymore. And I'm down to walking maybe 4 or 5 miles, not 12 miles every 8-hour shift. That's just one example. The idea of mixed SKU case picking to a shipping pallet. Think walk aisle sequence movement. It's like picking to a cart, except you're putting cases on a pallet. Same idea. Let's reverse the operation. Let's start doing putaways with these devices. And that can be a variation on a mixed SKU pallet pick, feeding a put-away operation. Then you get into the idea of replenishment, directing cases. Think of a cascaded replenishment operation. I have a pick-the-light system. I need to put cases on the back side of the case flow rack so that the operators on the front side can do their each picking. Well, I've got to pick those cases out of my reserve. That's an example of what we're talking about here. And then the idea of long-distance product movement, moving back and forth between A and B. Let's take a look at the first example. And the first example we're going to look at is goods to person. And that goods to person we're going to highlight in this pink area, salmon colored area here, all right? And so the vehicles receive instructions to pick up a cart, a mobile rack that has product on different shelves. They pick up the pallet, they pick up the rack, and they carry it down to this goods to person pack station. So you've got multiple AMRs queuing up and the front AMR is the operator is being directed either by a screen or by lights or whatever, what to pick from that cart, which is carrying this mobile rack, and then displaying and then depositing the product into cartons or totes that need to be then shipped out. Once that cart gets done, it goes and takes the mobile rack and it puts it back in the bins, the bulk storage area that this high density storage that we're talking about here, and then rinse and repeat. Here are some examples of robots that fit this. This is a very early on application of AMR, so there is a lot of choice with regard to who the vendors are that can do this kind of work. Essentially, you see the idea of the small AMR coming up underneath and picking up this tote. And in this case, they just kind of drag the tote or the mobile rack around because they've got wheels. This one is carrying it on its back. Down here, the Envia robot actually pulls a tote or a bin off of the shelf and takes it to the operator or takes it to a pick area. This center picture here from Scalog actually kind of shows the window. These robots would appear in this white area, basically on the other side of this image. They would appear in this white area, and then the screen here would tell the operator what to pick. And up at the top here, you see this little black box. That's actually a light beam, and it would shine on what portion, what shelf, what position of the AMR where the items were to pick, and then the screen would tell them how many. They would pick it and they would put it into the appropriate tote.
Hey, Tom. So, our experience here, obviously everybody knows Kiva got bought by Amazon, and then there's a bunch of different goods to person technologies that have actually been brought to market. And one of the things that Alpine's been helping a lot of our customers with is the appropriate sizing of the MSU, that mobile stocking unit, to make sure that you can accommodate as many pick faces on the mobile stocking units as well. And then the packing station or the PPS, really understanding the design based on your order profile and how many orders and batching and put to light. So, it's interesting. Everybody thinks about, the small, minute details of an MSU and how many are out there and the throughput and then the actual design of the PPS. And then more importantly, we're going to talk about some different goods to person technology and, your bell-shaped curve and the number of items are really going to also have an impact on what the right, either goods to person technology or AMR with the mobile stocking units are for your operation. So we've got a situation where we've got, 3 different types of automation in the same building based on the different order profiles. So just something to think about.
Totally. I mean, the devil is in the details with anything, right? And there's no exception. Here's an order to person approach. So here, the area we're going to focus on is over here on the right of the screen, and get our operators segregated out into the different zones. And in this situation, you have a carton induction station down at the bottom where the AMR shows up, and an operator down there is instructed what size totes or cartons or parcel, containers to put onto the AMR and what orders they are associated with. The AMR then learns what its instructions are, where does it need to go. It then takes off into the, in this case, we're looking at an each forward pick example where you've got shelving, an operator standing up can reach all the spots. And they go there, the operator sees them arrive, they see the instructions on the face of the robot, or maybe they're using a handheld or a vision, a vision device on their glasses or voice, and they're getting instructed what to put on the robot. The robot does its thing and moves forward into the next pick location as it finally gets all the stuff filled up. And then when the robot is done, it doesn't need any services anymore. It comes down to this packing station area. Operator here takes the stuff off the robot, and then the robot gets back in line to get more stuff on it. As I say, rinse and repeat. It's a very reasonably efficient operation. You can get some fairly high throughput through this. This is the example that I mentioned earlier where they were looking at almost 150 picks per hour per person in this area. What are some of the companies that do this? again, this is one of the earlier environments that this has been done in a lot. You've got these different suppliers, and you can see, similarities in how some of the robots look, but then again, they've got different stuff on top that they can carry around. And this then comes back to, how does it fit in your environment? So you see them here carrying totes that need to be processed. Here they're carrying the actual cartons that are being filled, minimizing, the additional handling later on.
Again, Tom, the devil's in the details on that last one, right? So we've got a candle manufacturer that has a system going in, and then all of a sudden they realize that their average order is about 50 pounds. So now they're weighing out their AMR. So you really need to think about the product, the commodity, what the order profile looks like when you design these. But I want to go back to something here. So on these smart carts, right? So a lot of your off-the-shelf WMSs do the cartonization, and then they actually have, batch cart picking logic. So where does that reside? Is that still in the WMS or is that in the AMR, Tom?
It is a negotiation between your AMR supplier and you, and how does it fit best into your IT architecture? I personally come from the camp that I think the WMS ought to be doing that, and then the AMR ought to be doing the execution of it, simply because the WMS has the visibility of the entire order. But some of the AMR guys have been building the software to where you can hand off the order to them and they will execute it. That works if everything in the order is in the area where the robot is going to be serviced. If not, you need the WMS to segregate out, here's the stuff I want the AMR to do over in the goods to person area or the order to person area. Here's the one I want an operator to do with a fork truck to pick cases for the LTL part of it. And here's the pallets that I want to go. It depends on the order. It is a part of the design. When I talked earlier about putting the IT architecture together to ensure the proper flow and process is carried from the beginning to the end, that is a big piece, not just what's the type of vehicle, how much load can it handle, and what does my warehouse look like? All of that has to go together. Now, the final one I want to talk about is the idea of long distance product movement. And this is the idea of I'm receiving product pallets from my stretch wrappers at the end of manufacturing line, and I need to put them away into my warehouse. And this is a long back and forth all day long. Do you want an operator doing that, driving a fork truck into the ground? I know when I worked at Proctor, I had one of my fork trucks, clamp truck actually. I had 3 batteries for that thing because it would burn through 2 batteries every shift. And it simply because of how much it was moving back and forth. And in this environment, I'm showing an image where I have an obstacle. I can't come across the shipping dock. I've got to go around to get to the other area. So here we just have the operator, the vehicle picks up at manufacturing. When it sees one, it drives over here, it sets it down. I'm showing it as a shuttle drive as opposed to it's actually going to go do the put away. There are vehicles that are capable of actually doing full-blown put away. A fork truck that's got AMR automation for the movement and then additional automation for inserting pallets in and taking pallets out of racks. But again, it's the same idea, rinse and repeat. So you got a vehicle running back and forth all day. And some of the examples that fit this, you've got, this is one of those robots that can actually lift up and put stuff up higher on shelves other than the floor. You've seen the Seagrid version, which is a pallet jack. You could also have a tugger. I know in one of my prior lives, we had a tugger that was pulling 5 trailers. And by the time we filled up the trailers, the tugger was pulling, I think 10,000 pounds. And it was hauling at 400 meters from one end of a really large warehouse to the other. And then down here, we've got a couple examples of AMRs working with what are called pickup and drop off stations. The Seagrid type could actually set it down on a floor, a spot on the floor. This is the type where it carries the pallet on its back. So it needs a device to pick it up from and set it down. And so now we come to the final takeaway part of this. And in this area, here's the things I want you to walk away from this presentation with, and hopefully I've given you enough information to where you can. One, AMR savings are real. There's studies, there's anecdotal evidence. This is not bleeding edge stuff when applied in the appropriate way. AMRs are, in many ways, just another material handling solution. So application of that technology is key. You heard Michael and I talk a couple times about the devil in the details. How does it fit? How do I treat it? You know, I've talked about, yes, it's another material handling automation solution, but you know what? An operator on a fork truck is a material handling solution. Maybe you think of these things like they're operators on fork trucks, only they have different assignments. The technology is proven. The guidance system on these BCs is amazing. I was the first guy at Proctor 200 years ago to successfully implement automatic guided vehicles in a manufacturing environment. I was really amazed that I talked them into trying the fourth time. There were 3 other projects before mine that didn't work, and we managed to succeed. And that was all wire guided. Today, you've got automatic guided vehicles getting additional lease on life in that they're putting AMR level controls and guidance systems on them to where they're not tied to a wire in the floor anymore. So the guidance systems are there, they're proven, it's fun to watch them. You can see this if you go to the different websites, you see them in the videos. They'll throw a box on the floor in front of an AMR. The AMR will recognize it and then figure out how to go around it. Or if the obstacle is too great, the AMR will turn around and find a new route to get to where it's got to go. The solution cost is flexible as well as scalable. We talked about the idea of the RAS versus a capital purchase, offsetting as a monthly expense instead of capital, having someone else manage the robots and the maintenance of the robots so that you're not actually hiring staff and trying to have them get trained on how to do that, or asking, you know, your in-house mechanics to learn an entirely different technology that may be a technical skill that they don't currently have. There's a lot of ways to be able to make this affordable. Some of the anecdotes, some of the case studies will talk about paybacks measured in months, not years. The fulfillment model is foundational to the success. And so the fulfillment model is the application of the right robotic form factor to the right real world material handling, product movement, task movement situation with the control system and the architecture of how the controls work together, appropriately applied, figured out, executed. And that's the AMR control piece in the last bullet.